Alright, so today we're looking at roots of and coefficients of polynomials. So our learning intention is to gain the knowledge in working and calculating the roots or coefficients of a polynomial algebraically. You'll be successful if you can calculate the sum of roots and the product of roots. Okay. So if you have a quadratic equation and they have the roots of alpha and beta, then it can be written as x minus alpha x minus beta. And when you expand all this, right, you get x squared minus x beta minus x alpha plus alpha beta. Collecting like terms and factorizing, you get x squared minus x lots of alpha plus beta plus alpha beta. Now that's how you'd write this quadratic. But quadratics can also be written as ax squared plus bx plus c in general form. Well, if we divide everything by the coefficient of a, we get x squared plus b over ax plus c over a. So equating coefficients, right, these are actually the same. So alpha plus beta is going to be negative b over a, because that's negative, but this is positive, so it has to be negative b over a. The product, alpha beta, is equal to c on a. Okay, so the sum of the roots is equal to the coefficient of negative b on a, and the product of the roots is equal to c over a. It's similarly with a cubic equation. So now we have three roots. We have alpha plus beta and gamma. All right, so if we multiply them out, we get x cubed minus the sum alpha plus beta plus gamma, x squared, plus alpha beta beta gamma alpha gamma of x, and alpha beta gamma equals to 0. Similarly, obviously writing it in the general form, a of x cubed plus b over x squared plus cx plus d, and dividing everything by the coefficient, making it mnemonic, right? The sum of the roots is equal to negative b on a. The sum of the double the roots is equal to c on a. And the product of the roots is equal to negative d on a. Notice the slight pattern between them. So if I were to have a quartic, right? If I have the four roots, alpha plus beta plus gamma plus delta, that's going to be the same as negative b on a. Now, the sum of the roots doubled, so alpha beta, alpha gamma, alpha delta, beta gamma, beta delta, gamma delta is going to be c on a. And technically, if I had a quadratic, this is just going to go up here, right? But I try to get the products of the roots all together. If you want to have the sum of three of the roots at a time, so alpha beta gamma delta, plus beta gamma delta, plus alpha gamma delta, yeah, that's going to be negative d on a. The products, obviously, this one's going to be c on a, negative d on a, e on a, yeah, and so forth. All right, let's do some examples. Given that we have 4x squared minus 9x minus 12 equals 0, and the roots are supposedly alpha and beta, we want to calculate it so it's a quadratic. We want to calculate what alpha plus beta is. Well, that's the same as minus b on a. In this case, it's going to be negative 9 over 4. So it's going to be 9 over 4. All right. The product is going to be c on a. In this situation, c is negative 12 over 4, so it's going to be negative 3. Now, 1 over alpha plus 1 over beta. Well, these are just fractions. So in order to add the fractions, I'm going to have to get the denominators the same. To get this to be alpha beta, I've got to times it by beta. To get this to be alpha beta, I need to times it by alpha. So really, I'm looking at alpha plus beta over alpha beta. Well, alpha plus beta was 9 over 4, and we're dividing that by negative 3. So 9 over 4 divided by negative 3 gives us negative 3/4. Okay. So given alpha, beta, gamma for this cubic, we want to find alpha plus beta plus gamma. So the same pattern, the sum of the roots individually is minus b on a. And in this situation, it's going to be minus negative 1 on 2. So it's going to be positive half. The sum of double the roots, well, that's going to be c on a, which is going to be 6 on 2, which is 3. And then the product of the roots is going to be negative d on a. And in this situation, it's going to be negative 2 on 2, which is negative 1. Okay. If I want to do 1 over alpha plus 1 over beta plus 1 over gamma, so it's the same as, I need the denominators to be the same. So this is going to have to be beta gamma, this is going to be alpha beta, and this is going to be, this needs to be alpha gamma. And this needs to be alpha beta. So it's going to be the sum of the roots, which we know is 3, over the product, which is negative 1, so it's negative 3. Alright, now we've got a quadratic, and we want to find alpha squared plus beta squared. So before I do that, I'm just maybe going to do these calculations. Okay. Now, I can't really find what alpha squared is plus beta squared is at the moment. So what I can do with those, I can think of doing this. Okay. That's not the same as that. Okay. It's not the same. However, let's work something out. If we did this, I would get alpha squared plus 2 lots of alpha beta plus beta squared. Now what happens if I move this to the other side? Okay, and that's what I wanted to find. I wanted to find what alpha squared plus beta squared is. Well, it really just is alpha plus beta, which at the moment is 3, let's square it, minus 2 lots of the product, which is 4. So that's going to be 9 minus 8, which equals 1. So alpha squared plus beta squared equals 1. Alright, this one's a good one to remember. Okay. Alright, we want to find k if x squared minus k plus 2x plus k plus 1 equals 0 has equal roots. There's 3 questions, and I'm probably going to work across ways in different sheets. So when I'm answering part A, so they have equal roots. So that means that, and it's a quadratic, it means that alpha, so we know that alpha plus beta equals minus b on a. All right. Well, it's saying that the roots are equal, so it's going to be alpha plus alpha, but that's still equal to negative b on a. So really, 2 alpha is equal to, now negative b, so it's going to be positive now, k plus 2 over 1. So that's basically, so alpha in this situation is k plus 2 over 2. Now, that's one thing that we know, but we also know that the products is equal to c on a. But the root is the same, so it's alpha times alpha, and c on a in this case is going to be k plus 1 over 1. Well, that means alpha squared is k plus 1. Subbing equation 1 into equation 2, you're going to get k plus 2 over 2 all squared equals to k plus 1, which is a quadratic which we can solve. Okay, so we get k squared plus 4k plus 4 over 4. Solving that, we get bring that over. To that. Yep. That cancels out. So k squared, bear with me, sorry, this should be 4k plus 4. Sorry. So, yeah, so k is equal to 0 in this situation. All right. Now let's look at consecutive roots. What that means is that roots follow each other. So instead of alpha plus beta, it's going to be alpha plus 1. Yeah, that's what consecutive means. And that's still going to be equal to negative b on a, and we know that that's going to be k plus 2. So what we have is 2 alpha plus 1 equals k plus 2. 2 alpha equals k plus 1. Now, the product of them is alpha lots of alpha plus 1. And that equals to k plus 1, because it's still equal to c on a. Well, that's alpha squared plus alpha equals k plus 1. Subbing equation 1 into 2, what we're going to get is we're going to get k plus 1 over 2 lots of alpha, which is squared, plus k plus 1 over 2 is equal to k plus 1. Okay, expanding that out, you get k squared plus 2k plus 1 over 4 plus k plus 1 over 2, k plus 1. That would equal x squared plus 2k plus 1 plus 2k plus 2 all over 4, which equals k squared plus 2k. Actually, what I'm going to collect like terms. 2k plus 2k is 4k. 1 plus 2 is 3. Going to multiply this by 4. Bring back everything over, so that's minus 3 minus 4 is minus 1. Okay, so we get a perfect squared. So in this situation, k is equal to 1 or negative 1. Okay, so we've got two possible solutions. The issue is now what we're going to do is we're going to plug in. When we've got k equals to negative 1, we get 2x minus negative 1 plus 2 is positive 1 plus 0, which gives you x minus 1, which gives you the roots of 0 and 1. So that works. But when k equals to 1, we get x squared, 1 plus 2, that's negative 3x, plus 2. So we're going to get x minus 1, x minus 2. So we get x equals to 1 and 2. So that also works. Beautiful. All right. Part C. One roots double the other. So really, we've got alpha plus 2 alpha equals k plus 1. So 3 alpha equals, k plus 2. So alpha equals k plus 2 on 3. Equation 1. So alpha times 2 alpha is k plus 1. So that's 2 alpha squared equals k plus 1. Now sub 1 into 2, which will give us 2 lots of k plus 2 on 3 all squared equals to k plus 1. So expanding, I get 2 lots of k squared plus 4k plus 4 on 9. So we get 2k squared plus 8k plus 8 equals 9k plus 9. And to factorize this, I would get 2k plus 1, k minus 1. So we get k value of 1 or negative a half. Okay, and they're your solutions. Okay, so it's really important to be successful in this topic. We need to remember the pattern of the sum of the roots doubled, sum of the roots tripled, and the product of roots. Yep. And then basically after that, it's the algebra behind it. Okay, so you need to be able to do the sum of the roots and the products of roots for your polynomial. Okay, thank you very much. Good luck.